Thank you, Mr. Chairman. Mr. Gerstenmaier, what we seem to be talking about here, I think, could best be described as the concept of extensibility, that technologies developed in the near future will be useful for future exploration as well. And extensibility prevents the development of dead-end capacities. Discuss with us for a moment how NASA ensures that its investments in in-space propulsion technologies have that ability.
Again, I think, as you've kind of heard from this discussion, we're kind of investing in a variety of technologies, so we don't pick one technology to focus on solely. We do the broad agency announcements to go look at a variety of technologies. We test those on the ground. We make sure they show promise. We have this requirement for this 100 kilowatt system to run for 100 hours. That's a good proof of concept that can be done on the ground. Then when that's kind of behind us, we know the system is mature enough, then it can start being fielded into an operational system. And for example, the concept of the habitat around the moon, that uses a 12.5 kilowatt system that Steve and the Space Technology Mission Directors have been investing in. That's a step up from where we are with electric propulsion today in the Hall thruster regime, but that's an incremental step moving forward. So I think by taking these steps, but also investing in these far-reaching technologies that are not yet, we're not sure what promise they have, that's also advantageous too. So we need to have that mixed investment philosophy of where we're looking at each one of these, but then we also look at the application moving forward. So we know today commercial communication satellites have electric propulsion on them. If we go to this 12.5 kilowatt size, that can remove the liquid apogee motors that are used from some launch vehicles. That even helps the commercial satellite industry more. So these things have application not only for NASA use, but also for use of the next generation of satellite technology. So I think we invest in a variety of activities, not knowing exactly where the outcome is, and we do it in a measured way that we can then get the best technology for future applications.
Along that very point, Dr. Chang-Diaz, Mr. Cassady, Mr. Pancotti, would you expand for a moment? Besides the government interest, and we just talked about this to a degree, how would you quantify commercial interest in high-powered in-space propulsion systems, gentlemen?
For our company, we started out actually as a purely private venture, and it was all funded by private investors. And our interest was not really to go to Mars, because going to Mars is really not a good business right now. So, but it is important to build the scaffolding that eventually will make it into a good business. And right now, the business of space is closer to Earth. And so our vision is more of the vision of the trucking business of space. You know, building essentially a logistics capability, an high-power electric truck. And we think of ourselves as sort of the diesel engine of space that enables all these trucks to be traveling back and forth between the vicinity of Earth and the Moon to make some revenue for the company. And then as needs expand, why we go further. So that's the vision.
Thank you. Mr. Cassady?
I would just say very similarly, we've been in the commercial side. We're supplying hardware now to most of the commercial satellite providers who fly electric propulsion. What we do see, as Bill said, as we're working with NASA on these higher power devices, there are other functions on those spacecraft that can be accomplished, like taking them from the drop-off orbit where the launcher leaves them to their final destination. Then there's a whole world of expanding possibilities that we're seeing open up. People are talking about these large 6,000 satellite low Earth orbit constellations. Those satellites have to go to individual points around the globe and be positioned. You can do that very effectively with a space tug, and I like Franklin's term, the space truck. We think of it very similarly. It's pretty, you know, multi-purpose. It really serves a lot of different functions. We see interest in the DoD world because they're looking at reducing the costs to get their assets where they need to be, and as well as improving the resiliency of the assets. And that all involves more maneuverability in space, which is, again, something that solar electric can provide to them. And then finally, I would say you know, there's going to be probably an expanding sphere of influence of the economy as we move out and do these exploration missions around the moon. We're going to start supporting people who want to go mine the moon and do things like that. They're going to need transportation systems as well. And so as we're moving out to Mars, they're going to be coming along behind us and doing things that are economically viable, and they'll need these transportation systems to support that.
Thank you. And Mr. Chairman, I see my time's expired.
Yes, sir.